Okay, so welcome students. Today we are going to see the experiment number 5, that is about semiconductors. So when we talk about the semiconductor, you first think about the electronics circuits, electronic PCB, printed circuit board, like that. And also you will be thinking, when we talk about the semiconductor materials, are the different devices which are related with automation and computer related thing, because semiconductor materials are extensively used in this segment. But if you talk about the semiconductor materials, what exactly the property of that material, what exactly the material is made up of, what are the different examples of these materials, this is what we are looking for in today's session. So we can see here that it's introduced as semiconductor is a solid state substance that can be electrically altered. Like, it has some properties which are not very common in the different materials. It has a very special properties. Like examples if we get of these elements which we can get in nature, that is silicon and germanium, and they are also attached or they are combined with the other elements, we call it as a impurity. Okay, so they has the property of insulator as well as conductor. Now why such kind of material is introduced? Okay, so we can say that this kind of materials possesses the special property, and because of this special property, that they can be converted into the conductor as well as insulator as of their parameters. So if we change the parameter, we can have the different usage of our material as a conductor or as a insulator. So that is a we can say that ये उनकी खासियत है. Now also if we talk about the semiconductor materials, they are having their dependency, or we can say that they are having the relation with the temperature also. It means if they are having a higher temperature, their conductivity try to increase. So there are different things which we are going to learn about the semiconductor materials today. So now when we talk about the semiconductor material, these are having the electrical conductivity at the room temperature is that of the conductor as well as an insulator. At the high temperature, it is becoming as a conductor. At a low temperature, it acts as an insulator. Now in semiconductor, there is a limited movement of electrons. Okay, limited movement of electrons. And why this movement is limited? Because it's dependent on the crystal structure. Okay, crystal structures of this particular material. So now we have two types of this semiconductor material. So basically two types is, like, first one is called as a intrinsic semiconductor. Now what is the meaning of this intrinsic semiconductor? Intrinsic semiconductor is like a pure semiconductor. Okay, it's a purest form of semiconductor. And second one is intrinsic and extrinsic. So when we talk about the extrinsic semiconductor, we are talking about the pure form of semiconductor is added with some impurities, and as per the type of the impurity, the semiconductor is separated, or we can say they are classified. Okay, so if the substance used for adding the in the germanium or silicon, then as per the type of impurity, we can add the free electrons or we are creating the holes. It means we can have the excess extra electrons in it, or we can have the deficiency of electrons. And because of these two conditions, both the structures of this particular material is completely varies, in which one is having a extra electron and another one is having a one or two electron less. It means one type can give the electron and one can accommodate the electron. So that is the beauty of this particular material. Okay, so now first one, which is we can say that it has extra electron or it has a deficiency of electrons. So what are they type called as? They are called as a N type. Here you have N type where the current carriers are negative, and another one is a P type. So there is one called as a N-type semiconductor, and one is called as a P-type semiconductor. Okay, so I hope it is clear to you. Okay, moving ahead with this, आगे बढ़ते हैं. Now, once we understand the types of these materials, now we come across the structure of this particular material. The structure में क्या होगा वो हम देखते हैं अभी. Semiconductor is a material with the, we are going to the structure now. अभी इसके पहले हमें एक बैंड थ्योरी के बारे में सीखना है, जो शायद आपने पहले पढ़ा होगा. I think it is visible now. So when we talk about the energy of electrons which are present inside the material, there are two types of bands are there basically. One is called as a conduction band and one is called as a valence band, where we don't have any comparison, you can say, or any difference between these two bands, then we call it as a conductor. And if the energy gap is between valence as conduction band is so large, then it will acting as a insulator. But in this particular diagram, in this B diagram, is my mouse pointer visible to you? Okay, so B diagram is indicating that semiconductor material is having a very small energy gap, and that energy gap is dependent on the different circuit parameters. Okay, and because of this gap, we are in a position where we can overlap this particular bands and either make this material as a conductor, or we can increase this energy gap, and by which we can make this material act as a insulator. Now, when this particular energy band gap is dependent on the interatomic spacing, and how we are going to change that for our semiconductor. Okay, so when we talk about the large energy gap between the valence and conduction bands in an insulator, that it's a ordinary temperature and no extra electrons can reach the conduction band. So whatever amount of energy that electron was having is already used to match, or we can say that breach that gap, but the electron is not in a position to go to the conduction band. Whereas in the semiconductor, the band gap is small, so that a thermal energy can breach that gap for a small fraction of the electrons. Some electrons are called as a thermally generated electrons, and because of that, there is chances that electrons will go into the conduction band and it will start acting as a conductor. Now let's see what exactly these energy bands are used for, how they are helpful when we talk about the application of semiconductor material. But before that, we must see the structure of our semiconductor material. So there are so many list. This is a list. Okay, list of semiconductor materials. So if someone asks you what are the different semiconductor materials, then group 4 elements will be considered as semiconductor, like diamond, silicon, germanium. Also compounds semiconductor materials are like silicon carbide, silicon germanide, and then we have aluminum antimonide. Okay, so these are the different types of materials which are called as semiconductor materials. So write down this list in your notebook.
सर स्क्रीनशॉट लेगा तो नहीं चलेगा?
Also, I will be sharing this PDF with you in the Google Classroom. So make sure you write down this complete list in your assignment. So this is the introduction, and this is a list of materials. So different materials, all the types of materials are there. The list is very big, and now we are going to see when we talk about this is the electron and hole structure. So this is what I was talking about, intrinsic semiconductor. Intrinsic semiconductor is like a silicon crystal in a different form of an insulator, because at temperature about the absolute zero, there is a finite probability that electrons in this particular structure will be loosed in its position and it may create a hole, or we can say that electron deficiency. Now if voltage we are applying across this material, then electron and hole can be again try to contribute in the flow of current. Okay, so ये current flow इससे हो सकता है, and because of which you can experience that there is a pure semiconductor is just doing the flow of electrons only for the amount of holes if there are any, and those are thermally generated, so no any extra electron hole pair which is possible. Okay, second one, when it is doping with the n type and p type semiconductors formation, then we call it as here that an added electron in the structure. So shared electrons for covalent bond. I will give you the diagram also where you can find the structure of semiconductor material. So one is intrinsic semiconductor. So this diagram, this particular diagram of intrinsic semiconductor, and give me a moment. So this is a trivalent impurity. Now what do you mean by trivalent impurity? Okay. See, now you can see here in the pentavalent impurity you have 5 external electrons. Can you see that? Just type 5 in the chat box. 5 electrons in the outermost orbit. Can you see 5 electrons here? Just type 5 in the chat box. Antimony जो impurity है उसमें 5 electrons है, so we called as a pentavalent impurity. Okay, so now when it's a boron impurity, boron or aluminium or gallium, which is also called as an acceptor impurity, then it is a trivalent impurity. Okay, and the pentavalent impurity is a donor impurity. So can you see 3 electrons at the outermost orbit here? Okay, perfect. ये डायग्राम आपको ड्रॉ करना है, आपको जूम करके दे देता हूँ. Is it visible now?
Yes, sir.
Okay, draw it. Done everyone? Just let me know in the chat box. आपको ड्रॉ करने को बोला था, हुआ क्या? कब बताओगे? Now, when we are adding this impurity, this trivalent and pentavalent impurity, what exactly the change happen in the structure of our semiconductor material that we are going to see? Say for example, the Si stands for the silicon atom. Can you see here silicon atom structure? Now in this, hello, am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
So in the silicon atoms, 4 atoms are there and they are sharing a impurity here. Now donor impurity is contributing for the free electron. Now how it is possible? Because in the silicon you have 4 extra, 4, not extra, you can say 4 electrons in the outermost orbit, and SB has another 5, 1, 2, 3, 4, total 5. Okay, we have seen earlier, right? यहाँ पे हमने देखा था. We have 5 electrons which you have drawn also. Now these 5 electrons is making a bond with 4 electrons from the nearby silicon atom, and they become total 8. Octal उनका बन गया. But one will be the remaining electron which will act as a free electron. Okay. So now adding a donor impurity will add an one extra electron in the overall structure of our semiconductor material. यहाँ तक समझ में आया आपको? आगे बढ़ते हैं. ये ड्रॉ करना है आपको, उसको हेडिंग देना है एन टाइप सेमीकंडक्टर. जैसे ही ड्रॉ करके होगा, जस्ट टाइप डन इन द चैट बॉक्स. Now there is a. Am I audible to you? Hello.
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay. So here is a spelling mistake. So this is not a N type. This is a P type because now the impurity which is added is a boron. Okay. Boron impurity यहाँ पे add किया है silicon में same structure में, where 3 electrons are there which are shared with the another silicon, outermost electrons. But there is one impurity is having an 1 electrons डिफिशियंसी, मतलब वहां पे एक और इलेक्ट्रॉन आ सकता है जिसकी वजह से 8 जो है वो पूरे होंगे, एंड दिस इज कॉल्ड एज अ होल, और वी कैन से डिफिशियंसी ऑफ द इलेक्ट्रॉन. तो यहाँ पे n के जगह पे सिर्फ p लिखना है and you have to draw this diagram. Go ahead. Okay, so I hope you have done with it. So now these are the different structures of semiconductor material. Now we are going to see the application of semiconductor material. So now if we talk about the application, as you know that this is a very common material for our electronics devices. So do you know any devices which are used in electronics? क्या क्या डिवाइसेस आपको पता है जो इलेक्ट्रॉनिक सर्किट्स में यूज होती है? सबसे पहले हमें अगर हम देखते हैं तो याद आता है वो है हमारा डायोड. डायोड के बारे में सुना है आपने? डायोड इज वन ऑफ द devices. Yes, just type these devices in the chat box. Second is transistor and then integrated circuits like IC जिसको बोलते हैं ना हम. IC is a short form of integrated circuits. Now then these particular devices are using the semiconductor material because of its reliability, power efficiency and the very low cost. Okay, so this is an advantage. Now if you talk about the industrial usage of electronic semiconductor materials, क्या होते हैं? जैसे कि हमने देखा है कोई माइक्रोचिप्स है, आईसीज है, वहां पर यूज होता है. सेकेंड इज ट्रांजिस्टर, एलईडीज, सोलार सेल में भी सेमीकंडक्टर मटेरियल इस्तेमाल होता है. माइक्रो प्रोसेसर, आपके मोबाइल फोन में जितने भी पीसीबी रिलेटेड डिवाइसेस है उसमें पूरा आपका ये सेमीकंडक्टर मटेरियल जो है वो यूज होता है. ओके, यहाँ तक क्लियर है सबको? परफेक्ट परफेक्ट. रोबोटिक्स में, देन डिफरेंट इलेक्ट्रॉनिक अप्लायंसेस में ये यूज होता है. ओके, आगे बढ़ते हैं. दीज आर अनदर एप्लीकेशंस ऑफ सेमीकंडक्टर डिवाइसेस. आई विल जस्ट पोस्ट दिस इन द चैट बॉक्स so that you can understand again. Okay, so we have discussed so many things about the semiconductor. So now you can just go through a data sheet of a semiconductor material and write a report on it. यहाँ तक क्लियर हुआ सबको? So एक्सरसाइज नंबर 5 मैंने आपके यहाँ पे पोस्ट किया है, तो उसको आपको सबमिट करना है विद इन अ वीक. तो नेक्स्ट वीक में मुझे ये 5 असाइनमेंट सबके रेडी होने चाहिए. सीआर कौन है आपके क्लास का? इसमें ड्यू डेट नहीं दिया ऐसा मतलब नहीं कि इसको कंप्लीट नहीं करना है. ओके, कितने लोगों को ऐसा प्रॉब्लम है कि सर ड्यू डेट नहीं दिया तो हमने नहीं किया? ऐसा है कोई?
नो सर.
नहीं ना?
नो सर, नेक्स्ट वीक तक हो जाएगा 5 के 5.
हाँ,
नेक्स्ट वीक तक हो जाएगा सर.
31 तारीख लास्ट देता हूँ मैं आपको, ठीक है? 31 तारीख तक होना चाहिए, ठीक है? तो आज के लिए इतना ही. मार्क योर अटेंडेंस एंड यू कैन लीव द मीटिंग. अभी किसी को कुछ डाउट है? इसको 31 दिया ना, इसको भी 31 देना है, ठीक है? ये वीक में आपको कंप्लीट करना है इसको, ठीक है? किसी को कुछ डाउट है?